This is Math 105, section 7.2. We're just going to look at some formulas and difference formulas in here for sine and cosine. We're not going to worry about tangent. And I don't ask you to memorize these. I will give you these on a test, so don't worry about memorizing these. Okay, so for sine, if we're taking the sine of two angles added, the angles being s and t, the sine of s plus t would be sine of s cosine of t plus cosine of s sine of t. Okay. And then for a difference of two angles, s and t, the sine of s minus t would be sine of s cosine of t minus cosine of s sine of t. So the only difference between those two formulas is that the plus is the plus and the minus is the minus. So you see we're taking sine of the first times cosine of the second, and then cosine of the first times sine of the second. And when we're adding, we add, and we're subtracting, we subtract. Okay. Cosine. Cosine of s plus t is the cosine of the first angle times the cosine of the second angle minus the sine of the first angle times the sine of the second angle. So this is cosine times cosine minus sine times sine for a plus. And then for subtraction two angles, s minus t, it would be cosine plus sine sine. So cosine of the first times cosine of the second plus sine of the first times sine of the second. Okay, so you can kind of see a pattern to these, but don't worry about memorizing them. Tangent we won't worry about for our purposes. Okay, so let's look at an example. Let's say we're looking at cosine of 75 degrees. Now, we can't normally do this by hand, but if we break it up into 45 plus 30, we can do it by hand, because we know 45, we know 30. Okay, so this is the idea, is that we're going to use these sum formulas, that we're given to do cosine or sine of angles that we know. Okay, so 75 is 45 plus 30, so this would be our s, this would be our t. Okay, so cosine of 45 plus 30 is cosine of 45 times cosine of 30 minus sine of 45 times sine of 30. So remember, cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 45 is also square root of 2 over 2. And then sine of 30 is 1/2. So this is what we have. Square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. Okay, so this combines, notice that we have 4 in the denominator. So square root of 2 times square root of 3 is square root of 6. And then square root of 2 is just square root of 2. So we can just leave it in this form. It's simplified form. So square root of 6 minus square root of 2 over 4. So we don't use a calculator for this. We do it by hand, and we get it in simplified radical form. Okay, using, angles we know, 45, 30, or 60, or whatever. Okay, the next one we're looking for is cosine of pi over 12, which we don't know. Okay, but if you take pi over 4 minus pi over 6, you get pi over 12. See, this would be 3 pi over 12, and this is 2 pi over 12 if we get a common denominator. So 3 pi over 12 minus 2 pi over 12 is 1 pi over 12. So pi over 4, remember, is like 45 degrees. Pi over 6 is like 30. Okay, so we're going to take cosine of pi over 4 minus pi over 6. Okay, so that's cosine of pi over 4 times cosine of pi over 6, following the formula, plus sine of pi over 4 times sine of pi over 6. So cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. Sine of pi over 4 is square root of 2 over 2, and sine of pi over 6 is 1/2. So again, just doing what we did before, simplify. This is going to be square root of 6 over 4. This is square root of 2 over 4. So our answer is just square root of 6 plus square root of 2 over 4. Okay. Again, just leaving it in simplified radical form, and don't worry about evaluating the square roots. Okay. But if you have a square root that you can simplify, do that. Okay, another thing you do with these difference or sum formulas is prove one of these identities, like this cofunction identity, cosine of pi over 2 minus u is sine of u. Remember, we talked about that in the last section. Okay, so using subtraction formula or difference formula, cosine of pi over 2 minus u is cosine of pi over 2 times cosine of u plus sine of pi over 2 times sine of u. Okay, these pi over 2 and u being our two angles. Okay, cosine of pi over 2 is just 0. Okay, so this first part goes away. Sine of pi over 2 is 1. So we're just left with, this disappears, and we're just left with 1 times sine of u. So we've proven that identity pretty easily using subtraction formula. So I may give you a problem like this in a test, so just so you're aware that you're given the formula, but you need to know how to use it. Right. Okay, and we can kind of see how this happens. Like, here's our angle u, right, on the right triangle, and then this would be 90 minus u, or pi over 2 minus u. So we can see that the cosine of this, cosine would be a over r, adjacent over hypotenuse, right? Would be the sine of this, which would be the opposite of our hypotenuse, a over r. So you can see that the cosine of this angle is the sine of this angle, and vice versa. The sine of u is b over r, and the cosine of pi over 2 minus u is b over r. Because remember that when you switch the other angle, the opposite and adjacent gets switched. So we can kind of see that identity just by using our right triangle. Okay, so we'll stop here. That's as far as we'll go. We'll look at some examples using sine in class because we just looked at cosine examples here. I also want to look at a short thing in section 7.3 just using our double angle formula and a half angle formula.